Hello, HVAC friends. In this video, we are going to look at the refrigeration cycle. And this video is probably geared more towards a student or a technician or a homeowner that has an interest in how their air conditioning system works. And this video will explain it to you, I hope, in detail. And if you have any questions, please leave them in the comment section. And as well, I'd appreciate a like and subscribe if you find this information of value. So if we first talk about the four main components of refrigeration cycle, you're going to see this in a refrigerator, you're going to see this in a residential unit, and even commercial units, or even the refrigeration system at the grocery store. It's all very similar. So the components we'll first talk about are the compressor, the condenser coil, which this is the outside unit at your house or an office, or it could be even on a roof of an apartment building or commercial building. Then we have the metering device and the evaporator coil, and I'll talk about each of these in detail. We'll start here on the left-hand side. So this equipment is typically on the inside, and it could be in an inside closet or an attic. And what we're going to talk about is the evaporator coil, and this is exactly what it looks like. You won't be able to see it because it's inside of a cabinet, and it's contained, and it's hard to get to typically. So, but I do want to share with you what it actually looks like. And the job of the evaporator coil, as we see here, is heat is absorbed from the inside. So refrigerant is running through this unit, this component, and it runs at about 40 degrees Fahrenheit. And as air blows across it, it picks up heat, both sensible heat, which is heat that you can feel, and also latent heat, which is hidden heat, or humidity. Okay, so that's the evaporator coil, and then it comes into the compressor. It's compressed and comes into the condenser coil and runs back through the metering device, and it starts over again. So let's start here with the suction line. So the evaporator coil, as we talked about, its job is to absorb heat. So this is refrigerant that is in these these um, these lines right here. And these are actual copper lines that you will see. In fact, right here is the suction line that we're going to talk about first. And this is our suction line, and this is our liquid line. So on the suction line, this comes out of the evaporator coil, and it comes out the refrigerant as a low pressure, low temperature vapor. So uh, it comes into the compressor, which the compressor sits in the condensing unit or the condenser, which is outside. And if you look on the back or on the side of this unit, you would see a large uh, copper pipe and a smaller copper pipe. The larger one is the suction line. And this uh, is if it's the summertime and it's warm outside and it's running for a few minutes, this suction line is going to be cold because this coil is running again at about 40 degrees. So it's not uncommon for this suction line to be maybe 55 degrees if you were to touch it. So think about a, cold glass of soda outside in the summer. Uh, a can or glass of soda, it's going to bead water and and be cold to the touch. So if you were to go outside and you see that this is running, and assuming it's operating correctly, that line would be cold. Okay. And again, it's a low pressure, low temperature vapor. It comes into the compressor, which is here, and the compressor's job is to compress it into a high pressure, high temperature vapor. So out of the compressor is a discharge line, and this line is about 175 degrees, and it's down in the bottom here. So, uh, uh, but if you were to touch it, you would feel it. It's hot. So it's a warm, hot, high pressure vapor. Okay. And it then is routed up here at the top, it- and it snakes around the entire unit here, and it makes its way down to the bottom, and it comes out the liquid line that we talked about, which is the smaller line over here. So this line right here, it is connected through the wall and through the attic or the closet, and it goes all the way to the outside unit here. Okay, so if we look here, we see that there's a fan on the condenser coil. So the fan sits right here on top. So the fan, it it runs and it's actually pulling air from the outside on all the sides. It pulls air across these coils that you see here and these fins and these tubes, and cools this high pressure, high temperature vapor. It cools it down and it condenses it into a liquid. That's why it's called a condenser. So the reason it cools down is because the fan is is pulling air that is cooler air across these coils, and the heat is being rejected into the ambient air. Okay, so a lot of people think that air conditioning is 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 inserting cold air into your house, but it's actually removing heat. So heat, even though this line is cold, this is actually heat being carried from your home and rejected to the outside. Okay, so if we go back down here to the liquid line, it goes through what's called the filter dryer. This could be outside, this could be inside, uh, depending on the installation. But it looks kind of like an oil filter, and it removes contaminants and as well moisture from the refrigerant. And then it goes through a metering device. Think of a metering device as like a, a spray bottle. So it's a liquid, and when we spray it, it comes out more of a vapor, right? It's a liquid vapor. So it also cools down the liquid, and as it goes in right here to the evaporator coil, which again is over here. So this is our liquid line, and if you look right here, this is our metering device right there. So it goes through the metering device, and then uh, uh, it comes here and it starts snaking around again. Okay, and the same on this backside as well. So it then uh, it boils, and I won't go into the details, but the reason it does is because it's a refrigerant and it has different thermodynamic properties than say water. So it is picking up heat. This is the return. So this is the uh, probably a register. It could be in your floor, could be in a wall, could be in a ceiling. And this is the air that is coming into the unit, the air conditioning system. And you really probably have a filter right here. So wherever you change your filter, this is where the return is. So um, the blower, it pulls the air in, it blows it across this coil, which is running at about 40 degrees, and uh, the heat both sensible, that you feel, and latent, that is humidity or hidden heat, uh, is picked up in this refrigerant, and it's carried away. And the result is then a cool air at about uh, maybe 55, 58, 60 degrees is coming out the supply vents or registers. Again, they could be in your ceiling uh, or in the floor, depending how your house is designed. Okay, but just to recap here, this is the inside unit. This is where we absorb heat from the conditioned space, both sensible heat that you feel and latent heat that is hidden or is humidity. And it's carried to the compressor outside and condenses back into a liquid uh, because the heat is rejected out here. So it's important when we think about things that a homeowner could do. Your filter is very important. That's the number one thing that a homeowner can do, is ensure that your filter is clean, because you want sufficient airflow to come across this coil so that it can effectively and efficiently cool your house. If your air filter is dirty, it doesn't get enough airflow. If it's really dirty and clogged up, this coil will actually freeze. I've seen it multiple times. So this coil here, the suction line, if you ever go outside and you see that it's frozen and covered in ice, it could be an airflow problem. It could also be low refrigerant and other things. But the number one thing, again, is as a homeowner, keep this clean. Uh, and along with that, on the outside, the air is pulling across and through these fins and these tubes, and it's important that this unit is kept clean. So as a homeowner, you could spray this down from the top to the bottom and remove the dirt and maybe cottonwood and dust and things like that, so that this unit is able to breathe and circulate air across it to reject heat and operate more effectively and efficiently and less electric bill as well. So I hope that you found this content helpful. If you do, I would really appreciate a like and subscribe, and any comments or questions that you may have, put them in the comment section. I'd love to read them. Thanks. Have a great day.